Welcome to this video on coding the line sensors for the Wizibot. If you've not made the line sensors yet, please go back to the previous session. You will find instructions on how to make a line sensing module. What you need to then do is create a second module. We're going to have one on the left and one on the right, so you will need two modules. Please ensure before you start this video that you have tested those modules using the code in the documentation. That should indicate whether the modules are working, and then we can fix those modules should they have any issues. If we were to try to use the line sensors in this project that weren't working, it would probably cause more confusion than anything else. Okay, so it's a good idea to test them first, otherwise you won't know if it's the line sensor module or whether it's the code that's the problem. Okay, so if you haven't done that now, if you don't have two line sensors, please go back and do that now. I have split down the process of coding the Wizibot line sensing into 5 steps. This video is the first step. Okay, you will find a video for each of these steps, and it will describe the code that we're going to be coding in for each of those steps. It will go into the details of that code and hopefully help you understand that code. As we build up that code at the end of each step, we should be able to run up the code, and then in most cases it's just going to output on the serial monitor to indicate whether it works or not. Okay, it's a good idea to do this type of coding to make sure that at each step, when you're developing a new program, that it is actually working before you move to the next step. Okay, otherwise, once you get to the final step, you run that code up, it doesn't work, and now you've got to go back and try and work out where and at what step it failed. Okay, so if you can test at the end of each step, it's a much better way of coding. In step 1, we're going to be loading the configuration from the EEPROM memory. This is the configuration we set up for the left and right motors a couple of weeks back. Okay, that's sitting on the EEPROM in the chip on the Arduino right now. We need to load that in because we're going to be running the motors and we want to know what speeds the left and right need to run at. I'm going to introduce tabs in this session as well. These are just tabs or files, different files for our code, and I'll explain that in a moment. In step number 2, which will be the next video, we will then look at actually sensing the lines themselves using those line sensors. Okay, I'm going to introduce you to the hash define command as well. We'll do that in step 2. In step number 3, we will then add a start button to allow us to start the line sensing. Okay, I'll explain why we're going to do that in step 3. In step 4, we will then add in the actual motor control itself, and then we'll be able to run the robot and actually see it following around a line. Finally, in step number 5, we're going to add in some additional functionality to add in the ability to detect drops underneath the robot. Okay, so in theory, if this robot was to drive to the edge of the desk, in theory, it should be able to detect that drop, reverse and turn away. Now, I say in theory because I want you ready to catch that robot, okay, because the sensors aren't perfectly placed for drop detection. You'll understand what I mean when we actually test them, okay. It's just a very good example of what we can use these line sensors for and how you can use a single sensor with slightly different code to make it change its behavior. So firstly, in this video then, let's have a look at coding with multiple files. You've probably noticed up to now we've used a single sketch file for each of our programs. Now, in short coding or short programs, that's absolutely fine. Okay, it's not a lot to read through. It's quite easy to find certain areas of your code. Obviously, as your programs start to get longer and they get more complex, it would be nice if you could split that code down into sections. We can do that. Okay, and in Arduino, we can actually create multiple files to contain our code. You'll probably notice when you create a new sketch, it actually puts it into its own folder with the same name. This is actually the project folder. Okay, you can put multiple files into this project folder, each with an extension of INO, which is a code sketch file. Okay, and what will happen is the compiler will read all of those files in as though they're one file. So what it'll effectively do, it will create a new temporary document in memory. It will copy the contents of all those files into that new temporary document, and then it compiles that temporary document. This allows us to split our code across different files and let the compiler combine it all again later on. Now you will notice in the example on the bottom there, this is the EEPROM code that we're going to be doing today. We have two files. We've got our main code file, which is our main sketch file, that's going to contain our loop and our setup functions. In this example, it's called code1 eeprom.ino, but we're also going to create a second file called configuration.ino. You will notice when it's loaded up on the Arduino IDE, we have two tabs, one for each of these files. The first tab will always be the main sketch file. It works out the main sketch file based upon that folder name. That's why that sketch file must always have the same name as the folder it's contained within. Okay, because that then knows that is the main sketch file that you load first. Okay, after that, it can load them in any order. Okay. Now, in this case, it's going to load code1 eeprom.ino in the first tab and then configuration.ino in the second tab. If you click on those tabs, it will show the code that's contained in those files. Okay, and then remember, when we hit the verify or the upload button, the compiler will actually combine all the contents together. Now, the important part of that is you can't repeat code in those two files. Okay, so if you have two functions, you can't give them the same name, even if they're split across those tabs, because the compiler is going to merge them in together, and it is going to be one document. Okay, so don't repeat your names, and make sure your variables and things like that don't have repeat names as well. Okay, so let's start coding our Wizibot with the line sensors. First thing I want you to do is create a new sketch in Arduino IDE. And then what we're going to do is we're going to create that new tab file. In the top right corner below the serial monitor, you should see three little dots. Okay, I want you to click those three little dots and then click on New Tab. When you click on New Tab, you should get a little dialog appearing. It says Name for New File. Okay, type in Configuration and click OK. Once you do that, you should actually see a second tab has now appeared in your project called configuration.ino. Okay, we now have two tabs. We can now type in our code. Selecting that configuration.ino tab, I want you to type in the following code. By all means, pause this video, type in this code, and then resume this video. The code that you've now typed in, I will give a brief description of what it's doing. Okay. What we're doing with this is we're going to load the configuration from the EEPROM. If you remember back when we did the EEPROM code, we had 3 bytes that we wrote in the memory. The first byte we were always going to set to the character W. Okay, this W just indicates that calibration has been run on this robot or this Arduino before. Okay, so the first thing we're going to do in this code when we're loading up the configuration is to check to see if that character is there in that first byte. Okay, so we do EEPROM.read in the first byte. And we check, is that equal to that 87, which is a capital W in ASCII. If it's equal to 87, what we then do is we simply load in the other 2 bytes with the settings for the left motor speed and the right motor speed. If the calibration is not found, okay, so that's that red box down there, then what it's actually going to do is it's going to load in the defaults, which is just 150, 150. So they're just set to the same speed. It probably won't drive in a straight line. You didn't run the calibration, okay, but at least it's going to have something to work with. You will notice as well that with serial.printing, just to help us test, okay, so when we run up this program, it should tell us if it successfully loaded the EEPROM or not. Okay, so we're just doing serial.prints just to indicate if it worked or not. Once you've typed this code in, I want you then to move back to the other INO, or the code 1, in this case, EEPROM. That's your main sketch file. So if you haven't saved it yet, I definitely recommend you save it at this point. Okay, and once you've saved it, I want you then to type out this very simple bit of code here, and then resume the video. Now you've typed in that code, I just thought we'd give a brief overview of what's going on in this code. The first thing we're doing is we're simply doing that #include command to include the EEPROM.h library file. So that goes off, grabs it off hard disk, and loads it into memory. Okay. Now it knows how to handle that EEPROM. The next thing that we're going to do is we're going to declare our variables that are going to store the motor calibration settings that we are loading from the EEPROM. Okay. So these are the variables that are going to store the values that have been loaded in configuration tab. Next thing that we do in our setup function, we start the serial begin just so that we can start transmission between the Arduino and the PC so that we can see what's going on. And then we also make our call to our load configuration function, which is now located in the configuration tab. So you just type that into the configuration tab. If you go back to the configuration tab, you should see void load configuration. That is just going to get called from setup here. Okay. So all of that code, when we hit the compile and verify button, if you do that now, the compiler will now combine that code together into a single file. It should run it up, and if you open up the serial monitor, you should see that it says that it's found the configuration, and it should tell you the values for the left and right motors. If that is all working, that's great. You've finished this video. Move on to the next step. If it's not working, obviously find me in the session. If it's saying it's not managed to find the configuration, maybe you've changed your Arduino, or maybe you never ran the configuration in the first place. Okay, go back to the motor configuration code, run that on your Arduino, set up your motors with your left and right motor speeds. Okay, follow that configuration settings tutorial that's in that week. Okay, and then come back, run this program again. Okay, and now it should work. Okay, so hopefully it's all working. You can move on to the next video.